Hello, it's Caracol, and I'm going to be explaining scaling problems. So the first thing I want to say about scaling problems is that they are power functions. And what we know about power functions is the general equation, which I will be explaining throughout the video, is equal to y equals ax to the b. So the setup of this equation shows that y is dependent on x. So that makes x the input and y the output. And a point in this function is x0, y1. So if we're going to solve for problems, just a general problem in the equation, we'll start with the input, of course. And so an example would be x1 is equal to m, which is just a random number, x0. I think an easy way for me to demonstrate this would be to show a visual. So I'm going to draw what we call a function machine. And so we have the input, which we know to be x now, to the function part, which we know is y equals ax to the b, and that will produce the output, which is y. So we're going to plug this in to the function machine. So x is going to be x1, which is going to produce this part, which is a x to the 1, b, which produces y1. And as you see up here, another way to write x1 is mx to 0. So mx to the 0 into the function machine produces a x0 to the b, and that produces, well, here we're distributing this exponent, so that's a times mb x0 to the b. And then to make it easier, we can redistribute again. And this is going to be mb times ax0b. And then, as we can see here, y equals ax to the b, just like right here. And so y times mb, y0 times mb, is part of what makes this function happen. And what this all kind of shows is that when the input, which is right here, you know to be x, is multiplied by m, which is the random number, output, which we know to be y, is multiplied by mb. And that pretty much just shows how the equation works. And yeah, that's all.